So the interim report for the Opal Tower investigation has been released. Let's have a look. Good evening everyone and welcome to another episode of Heiser Says. Today I thought we'd go through the Opal Tower investigation interim report. Now I've got my stein of black coffee and I've got the report in front of me and I wanted to go through the whole thing. So this is going to be a long episode, but I think it's important to read this ourselves and not just, grab the highlights from the journalists, because I'm actually quite interested in it. You see, we've got a nice picture there of the tower. So it's the independent advice to the New South Wales Minister for Planning and Housing. It was published yesterday on the 14th of January 2019. So let's go through the executive summary here. So at the request of the Honourable Anthony Roberts, Minister for Planning and Housing, an investigation was carried out into the cause or causes of structural damage to the Opal Tower at Sydney Olympic Park, which was first observed at Christmas 2018. What a time for it to be observed. The investigation also considered possible remediation action to repair the damage to the building. This interim report presents the preliminary findings of that investigation. Further information is required to enable definitive conclusions to be made about the cause or causes of the damage to this structure and the proposed remediation. So they haven't reached a conclusion yet. However, based on the information available to date, the following opinions and findings of the investigation are presented. So number one, the building is overall structurally sound and not in danger of collapse, but significant rectification works are required to repair and strengthen damaged hob beams and in some cases panels that rest on them. Point number two, a number of design and construction issues have been identified, a combination of which probably caused the observed damage to some structural members in the Opal Tower building. Further information is required to ascertain the relative materiality of these issues to the cause of damage. 3. The viabilities of residents re-entering the building extends beyond the scope of the structural issues considered here, and hence beyond the scope of this investigation. That's probably going to be very frustrating to all the people that still can't live in their close to $1 million homes. You really have to feel sorry for them. Nevertheless, notwithstanding point one above, before residents reoccupy the building, the designers must ensure that no structural member is overloaded as a result of any load redistribution likely to have occurred as a consequence of the observed damage to the structure of the building. A proposal for staged rectification of the damaged structural members of the building has been considered and agreed in principle. However, it is recommended that independent and qualified structural engineers should be engaged to check the final proposal in detail before major rectification works commences. And point 5, further analysis should be undertaken on the structural design of the hob beams and associated structural members with similar details and considerations should be given to strengthen them wherever they occur throughout the building. So I think this is a design issue. Okay, well, let's go through the introduction. The Opal Tower is a high-rise residential building located in Sydney Olympic Park, New South Wales. It consists of 36 stories above ground and 3 basement levels below ground. Construction of the building was completed in 2018 and occupation of the 392 residential apartments commenced in the second half of 2018. A photograph of Opal Tower is shown in Figure 1. The building is characterized by its original overall triangular prismatic shape with a number of inserts in the 3 external faces of the building. See Figures 1 and 2. Where are they? Oh, we can see them here. These architectural features are referred to as slots on some design drawings. On Christmas Eve 2018, residents of the Opal Tower reported loud noises, including a loud bang reportedly of internal origin and presumably associated with the structure of the building. Early investigations of the source of these loud noises identified cracks in a load-bearing panel on level 10 of the building, forming one of the exterior walls at the base of one of the insert slots. Later investigations revealed further cracking of the hob beam supporting the cracked load-bearing panels. Subsequent investigations also identified other cracking concrete structural members at level 4 in the building, again at the base of an insert feature. So it seems to be a recurring issue. Because of safety concerns, residents of the building were evacuated first on Christmas Eve. Christmas Eve. They were subsequently allowed to re-enter and then asked again to depart the building on December 27th, following more detailed checking of structural elements and specifically the identification of additional structural damage on level 4 of the building. Pardon me, I need a coffee break. On December 27th, 2018, the New South Wales Department of Planning and Environment engaged Professor John Carter, Mark Hoffman to investigate a number of matters related to the cracking of the concrete structural members in the building, including the likely causes of the observed cracking. Following initial investigations, Professor Stephen Foster was also engaged to assist in the investigations on the recommendation of Professors Carter and Hoffman. This interim report contains a brief description of the investigations carried out to date and present preliminary findings and opinions. These findings and opinions may be modified as more information comes to light during the ongoing investigation. Terms of reference. So, the terms of reference of the investigation have been provided verbally by the Secretary of the New South Wales Department of Planning as follows. Number 1, determine the basis of the failure, what happened and how. Number 2, the immediate steps that need to occur to ensure the safety of the building for its occupants. Number 3, any other recommendations on what needs to happen to avoid incidents like this in the future. This interim report provides preliminary findings for the first 2 of these terms of reference, viz. The basis of the failure and the steps to ensure the safety of the building, which have been the focus of our investigation to date. So they haven't gotten to the point of making recommendations. I'm sure that'll be a lengthy process, frankly, to see what's happened. So the building structure. The Opal Tower is a reinforced concrete building with post-tension concrete floor slabs. It is a reinforced concrete central core structure which houses the lifts and fire stairs. The floors of the building are supported by the core walls and reinforced concrete columns and precast concrete elements. A particular feature of the building is the slots located on each external facade of the building. See figures 1 and 2. The walls of these insert slot sections of the building are constructed largely from precast reinforced panels, with some cast in situ panels. The walls, composed of these panels, have been designed to carry gravity loading, effectively acting as columns, transmitting vertical loads from floors above the insert slots and from floors intersecting them to the individual supporting columns below each insert slot feature. The columns of the building are founded on individual pad footings. We'll note that there. And the central core is supported by a shallow spread footings. All footings are founded on shale bedrock. Okay? So some people in the comments on previous videos were arguing that it's just all swamp and sand, so it kind of throws that argument out if it's been founded on bedrock. The major structural design of the building was carried out by WSP, an international engineering services company. The design of the post-tension concrete floors was carried out by the Australasian Pre-Stressing Service. The precast wall panels were fabricated by Evolution Precast Systems. The building was constructed by Icon Co., an Australian building contractor and part of the Kajima Corporation Group of Japan. So, investigation activities. To date, our investigation has included the following activities. 1. Multiple visits to the Opal site. An inspection of the damaged structural members in the building and the members in similar locations. Review of the design of relevant sections of the building and related documentation, review of construction records and quality control records, viewing of security camera recordings of the garden area in the slot on level 10 where damage to the panel was first observed, and discussions with representatives of the building's structural designers, WSP, and builder Icon. This is not really a Christmas gift you want, but it shows you who, they haven't talked to the certifier, and the media was trying to create this whole shitstorm, frankly, about the certifier based on a few complaints when, it's nothing to do with them, frankly, because they were depending on WSP. WSP isn't a small firm. They're a large, well-known, global-sized practice. So note that at the time of compiling this interim report, we had yet to receive all requested materials relating to the design and construction of the building. That's interesting. I wonder why that is, because you should be able to just burn off a CD and hand it over. Maybe they haven't subpoenaed it. These activities have focused on various structural elements in sections of the building located on level 3, 4, 9, 10, 16, and 26, as well as the basement level B3. All areas of known structural damage, both major and minor, were inspected. In particular, we inspected all insert slot regions of the building, focusing on the structural panel walls and their supporting hob beams, and the floor plates adjacent to the damaged hob beams. The observed damage. During the numerous visits to the site of the Opal Tower, we inspected and re-inspected a number of locations where significant damage had occurred to load-bearing concrete members. The areas of significant structural damage are located on levels 4 and 10. The approximate locations of these damaged regions are shown in figures 3 and 4. Let's have a look here. So here you go. We'll just have a look here. Here's 4, here's 10, and they've got damage here, damage there at level 10, significant damage there. Okay, you can see here. So here's the inner core with the fire stairs, and these are where these walls are transferring the load down. You can see the same thing, damage here. Level 4 major damage. Significant damage. Okay. Let's get back to the article, or to the report. Photographs of some of the damaged concrete structured members are shown in figures of 5 to 10. Specifically on level 10, a hob beam spanning between columns C21 and C38 along grid line C, shown in figure 4, and the panel A resting on it, see figures 5 to 8. Cracking was also observed in the floor plate adjacent to column C21, see figure 9. Let's have a look at some of those pictures. Ooh, here we go. You can see the cracking. That's, yeah. Damaged precast panel in this figure. Damaged precast panel at level 10 above column C38 after some broken section of concrete was removed. Hob being in the vicinity was 38 prior to pouring concrete. Top photo inside the building on January after cracking. Okay, exposed rear. They're checking the spacing of it, so they're doing everything here. So let's get back to that, to the report. Okay, on level 10, a hob beam spanning between these ones. Yep, cracking was also observed on the floor plate adjacent to the column in figure 9. On level 4, a hob beam spanning C16 and C34 along grid line A, shown in figure 3, also appears to be major damage. Hob beam spanning between C2 and C22, and cracking was also observed in the floor plates between levels 3 and 4. It is noted that the vertical load lines along which these 3 pieces of observed damage occur all appear to be different, and hence the 3 areas of damage are likely to be unrelated to each other. That's interesting. That's very interesting. That's worrying. But this deduction requires further detailed examination before it could be confirmed. Yeah, you never know how damage can spread to a building. It's quite fascinating. From the security camera footage referred to previously, we've observed cracking in the bottom corners of the bottom panel on level 10. The timestamp on this video recording indicated that the cracking of the panel commenced at approximately 2:16 on Monday and continued for 8 seconds. Now, while we're discussing all of this about buildings falling down and everything, I'm going to make a plug for a book. It's called Why Buildings Stand Up, Why Buildings Fall Down. They're 2 books. And I'll link to it on the to the Amazon entry for it in the description below. But this is a book we had to read in first year architecture school, and particularly Why Buildings Fall Down was fascinating just to hear about all these buildings, all the disasters that have happened and why they're falling down and what the issues were. If you're interested in learning more about this topic, just in a more general perspective, I would recommend that book. It's easy to read. Anyone, I mean, come on, architects can read it. So it means anyone can. So back to this. So possible causes. After inspecting the damaged areas of the building, we initially hypothesized a number of factors that may have been a contributing cause of the observed cracking of the concrete hub beams on levels 4 and 10, the damaged precast panels on level 10, and the damaged floor plates between levels 9 and 10 and levels 3 and 4. These factors are categorized as follows. Number 1, environmental factors such as major storms, heavy rainfall, high winds, and extreme changes in temperature causing unexpected and potentially damaging loading on the building. 2. Poor quality construction materials. 3. Issues with the foundations, namely differential settlement of the pad footings supporting the building's columns. 4. Flaws or errors in the design of the structural system. 5. Poor quality workmanship or errors during construction. We considered and assessed each of these factors in some detail and ultimately concluded that not all of these factors were relevant to the damage observed to the Opal Tower. Further details of this assessment are provided as follows. Okay, environment. In particular, the environmental factors were considered to be highly unlikely to have contributed to the damage because the meteorological records for the few months preceding the failure, and particularly in the period immediately prior to and on the 24th of December, showed no extreme or adverse conditions. Okay, sorry all the people that wanted to blame this on climate change. Looks like you can't. The rainfall records show some significant downpours in the months leading up to Christmas, but they were considered not to be unusual. Materials. There is no evidence in the documentation we have reviewed to date to indicate that the materials used in construction were inferior in quality or did not meet the specified requirements. We therefore infer that poor quality construction materials are unlikely to have contributed to the damage observed. Okay, now one thing to realize here, they're inferring this based on the documentation. Okay, so it depends what they mean by documentation. Do they mean receipts from the builder for particular supplies, and have they identified that paper trail to ensure that what was actually put into the building was what was documented by the designers? Or are they just referring to what was documented by the designers? So that's the question. I'm sure they would have done it properly, and I'm sure they would have, got as much evidence as they could. But remember, this is only an initial report, so they may still, they've admitted they're still waiting on additional information. So, let's wait and see. I'm not, honestly, I think they're right. I don't think, inferior quality isn't a big issue in Australia, but then again, it's starting to happen. Masters happened, and, you used to get a lot of bad steel from China. So yeah, we'll see. Foundations. In general, differential settlement of the footings of a building can occur for a variety of reasons. For example, neighboring columns may experience large differences in their compressive loading, or the ground beneath neighboring footings may vary markedly in terms of stiffness and strength. Differential settlement is also likely if the ground beneath some footings, but not others, may soften over time, perhaps due to local wetting of the ground beneath the footing causing softening of the foundation material. The records we inspected revealed that all column footings of the Opal Tower structure were founded on shale of low to medium strength, with the majority being medium strength. The records we reviewed indicated that the spread footings supporting the tower core and all but 2 of the 40 individual pad footings supporting the tower columns were inspected by a geotechnical engineer prior to the pouring of concrete to form the footings. All inspected footings were certified by the geotechnical engineer as suitable to carry a maximum load allowable bearing pressure of 3.5 MPa. We could not find inspection records for columns designated as C8 and C40, see structural drawings, yada yada yada, for column designations and loadings. However, if differential footing settlement had been a contributing cause to damage to the building, and specifically the damage observed on levels 4 and 10, we would have expected to observe crackings in the floor slabs and at floor column connections in the lower levels of the building. Our inspections of these areas of the building indicated no such damage. So, on the basis of this observation and the documentary evidence of the condition of the shale foundation at the time the footings were poured, we concluded that differential settlement of the column footings is unlikely to be a contributing factor to the structural damage observed on level 4 and 10 of the Opal Tower. Well, there you go. That's very interesting. Design. Okay, preliminary consideration of the bearing capacities of the hob beam at the locations of the connections of the beams with columns C21 and C38 on levels 10 and with columns C16 and C35 on level 4 indicate factors of safety lower than required by standards. To this date, we are still awaiting further details of design analysis to further consider this factor. Okay, now that's interesting. But then you have to understand as well, engineers will have significant factors of safety, and the standards could change. I know they have on certain ones. But see, this is the thing. As a designer, as an architect, we're completely dependent on the engineers for this. It's their responsibility. We'll be at pains in the arse for them and try and get them to do amazing, crazy things and really push the limits to get a beautiful building. But you need to, rein it in when they say, nah, Florian, you can't, not possible. So construction. There are a number of points noted on level 10 of the building where construction differs from design and or standards. Okay, here we go. Grouting. Design drawings indicated that full grout coverage was expected between the panel and the hob beam. However, during construction, only the inner surfaces of approximately 110 millimeters wide appear to have been grouted, leading to an eccentric bearing load on the hob beam on level 10. It should also be noted that approved shop drawings show the grout extending over only the inner portion of the hob beam to panel connection. So there you go. There's a difference between what was designed and what happens in practice. And depending on the way the building is procured, if you're working for the builder under a D&C, design and construct project, it really limits your ability to use your authority to the designer to force them to do it, because they can just go no and get away with it. So I'll be interested to see what happens, what more we're going to find out in this. B. Location of reinforcing steel in the vicinity of the connection between the hob beams and column C21 and C38 on level 10. In particular, inadequate cover concrete due to encroachment of discontinued anchored column bars into the cover zone and the placement of an electrical conduit within the cover zone in this area. Wow. Okay. Having sufficient cover over reinforcing steel and concrete is very, very important. It is what leads to cracking. It will affect the structure. It'll affect the reinforcing. It won't work. My father, when he first immigrated to Australia, he was given a job on the concrete housing project in Victoria, and he had to discover why it was cracking, why all these concrete houses were cracking, because he had experience with precast panels from Germany. And it was because there was insufficient cover. So C, a dowel bar between the hob beam and the panel was observed to be incomplete, possibly cut during construction. Oh, there you go. D, the original design drawings of the building indicated precast concrete panels that were the same width as the hob beam upon which they rested, 180 millimeters. These were subsequently manufactured to be 200 millimeters in width. The panels were erected so that they overhung the inside face of the hob beam by approximately 20 millimeters. That can make a difference on a panel. If you've got, a beam like this, and you've got your panel hanging over, that's different. That's going to adjust the way the load's getting distributed. And this happens all the time. You know why they would have done it? Because getting a panel 180 mils thin with the cover, it's probably harder and a bit more work. That's why in a lot of industrial buildings, it's better to, they'll often chuck a bit more concrete in there to make it easier to do. Okay. Inadequate tensile capacity in the horizontal direction in the bottom region of panel A that rests on the hob spanning columns C21 and C38. There is compelling evidence indicating that the wrong sized reinforcing bars were placed in these during manufacture of this particular panel. 20 millimeter diameter bars were used instead of 28 millimeter diameter bars. Let's see figure 8. Let's go. Let's have a look at that. Figure 6. Figure 7, figure 8. There you go. Huh. So they're skimping on the bars. They're getting the cheaper ones. Uh-huh. Well, isn't this interesting? Because what our poor certifier that was chucked under the bus, he needs to depend on what's been provided. The shop drawings would have been signed off. I'd want to see the panel's shop drawings. Who reviewed those? It would have been the structural engineer had to review them, sign them off. Do you think they actually built them like the shop drawings? Because that's the thing. You get shop drawings, and this is, say you get concrete panels on a building, precast panels. The manufacturer of those panels will issue you, a set of shop drawings, and you have to review them. So the architect reviews them, the structural engineer reviews them. Hell, even the project manager should review them to just check to make sure you discover anything. But you can't approve them. You can say it's generally in conformance with your design because it's his responsibility. It's the manufacturer's responsibility. You kind of doing them a favor. But, you know, if it said 28mm bars and you say, oh yeah, that matches up with the structural, good. But they still build it with 20mm, there's nothing you can really do. Nothing the certifier can do, nothing anyone else can do. Maybe they just bug it up during construction. At this stage, it is not possible to state a definitive cause for the failure of the hob beam on level 10. However, it is likely that a combination of some of the above design and construction issues led to the observed structural damage on level 10. There were other construction issues observed, such as incorrectly anchored shear reinforcement in the hob beam, which were considered immaterial to the failure. In regards to the timing of the observed damage, it is likely that the damage occurred after progressive buildup of loads on the structure as apartments became occupied, culminating with the observed failure on level 10, at level 10 on the 24th of December. The architectural design, where the major damage to the hob beam has been observed on level 4, is quite different to that of the damaged hob beam on level 10. Namely, the panels commencing at level 4 are manufactured in 2 sections rather than 1, and the width of the hob beam is 320mm under the inner panel and 180mm under the outer panel. The cause of the damage observed on level 4 is still being assessed, and the bearing of the damaged hob beam on its supporting columns is being studied in detail. Okay, so proposed rectification. What are they proposing to do? We understand that soon after the structural damage to the building was observed, WSP instigated a program of installing props under the damaged areas as a temporary measure to ensure the safety of those areas of the building. WSP has briefed us on the structural principles behind their proposal for permanent repair of the damage observed on level 4 and 10 and the strengthening of the associated structural members, viz. The hob beam and the lowest panel at these sections. We understand that WSP is proposing that these rectification works shall be carried out in a 3-stage process. It is our opinion that the structural principles behind WSP's proposal for rectifying are sound. In particular, that effective structural members will be strengthened by the proposed measures. However, we have not received details of structural analysis of the proposed rectification, so they haven't given them the actual calculations yet. We recommend that WSP's detailed plans for the proposed rectification works should be checked by an independent qualified structural engineering organization. We understand that strengthening of the hob beams at all levels of the building with similar details, 4, 10, 16, and 26, is also being considered. The observed damage on levels 4 and 10 will have caused load design to be taken by the damaged elements to be redistributed to other parts of the structure. Consideration should be made of this load redistribution to confirm that the outer parts of the structure have satisfactory capacity to carry the new loads. Wow. There you go. So they may need to redo all their calculations based on this change to the building. Conclusion. So at this interim stage, we are still waiting further information to enable definitive conclusions to be made. However, we can state the following. 1. In our opinion, the building is overall structurally sound and not in danger of collapse, but significant rectification works are required to repair and strengthen the damaged hob beams and in some cases the panels that rest on them. 2. We've identified a number of design and construction issues, a combination of which probably caused the observed damage to some of the structural members in the Opal Tower building. 3. The viability of residents re-entering the building extends beyond the scope of the structural issues considered here and hence beyond the scope of our investigation. I feel sorry for those people every time I read that. Nevertheless, notwithstanding our first conclusion, before residents reoccupy the building, the designers must ensure that no structural member is overloaded as a result of any load redistribution likely to have occurred as a consequence of the observed damage to the structure of the building. We have considered the proposal by WSP for stage rectification of the damaged structural members of the building and agree in principle with the rectification solution proposed by WSP. However, we recommend that independent and qualified structural engineers should be engaged to check the WSP proposal in detail before major works commences. We also recommend that further analysis be undertaken on the structural design of the hob beams and associated structural members with similar details, i.e. levels 4, 10, 16, and 26, and consideration be given to strengthening them at these other locations throughout the building. So by Carter, Hoffman, and Foster. So let's have a look at some of the images. General view of the Opal Tower. Insert slots. Close-up of 6-story slots, so you can see here. And there's the damage. So here are your apartments you're getting. Not very... Oh, if that's a whole... Yeah, that's a whole apartment there. You'd hope. Minor damage, significant damage to see... Oh, extends 1.7 meters. Oh, look here, look at the crack in there. Bugger. Yeah. This is interesting. So what do you guys think? You know, even if we had a clerk of works on site observing the construction, if it was a fabricator element off site, you know, they'd have to go there and observe the panels as well. So I will want to keep following this to see what happens. Photographs of the hob beam resembling column 38 at level 10 prior to pouring concrete. Top photo inside the building on the 8th of Jan 2019 after cracked covered concrete removal middle, and outside on the 8th of Jan 2019 after the garden and waterproof covering removed bottom. So yeah, look at the cracking there. That's not good. Photograph of the outside top and inside bottom of panel A at level 10, just above the hob beam adjacent to column 21, indicating N20 reinforcing bars at 100mm center in the lower portion of the precast panels. Note the exposed gap between panel A and the hob beam and the black plastic sheath for the joining dowel. Top photo right of the tape measure. Shit. Why can you see that there? Bugger. Photograph of the damaged floor slab adjacent to column C21 on level 10. Oof. There you go. Where are these ones? Oh, look at that. You don't want to see that. Photographs of damaged hob beam on level 4 under column C34, before, top, and after bottom cracked concrete removed. Photograph of a crack in the floor plate between levels 3 and 4. It's not what you want when you're paying close to, you know, hundreds of thousands, 800, 900 million bucks for an apartment, is it? You expect a certain level of quality. You expect to have the right Rio bars in there, in your panels, holding up your building. So guys, I know this was a long one. Thank you if you stuck through and watched everything with me. So, and listen to me. I think this would have been a good one for, you know, a car journey to listen to. What do you think? You know, they say the building's structurally safe. Would you try and nab a bargain? Go in there right now, offer them, you know, $500,000 cash for $1 million apartment. People might take it. Might be scared. I wonder what recommendations you think can be put in place to address something like this. If developers start advertising, you know, stamped approved by a clerk of works, you know, all construction observed, try and educate the public about these type of things. But, you know, it could be a lot worse. It really could be a lot worse. And people are responding, and, you know, politicians are pushing for these type of reports to be done so we can all learn from it. I think that's, you know, that's a good thing. I feel sorry for the people that are, you know, can't stay in their home, but at least there's no danger of the whole building coming down. So guys, thank you all very much for joining me for this episode of Heiser Says. Please like, share, and subscribe, and I will join you again tomorrow. Bye for now.